Hello everyone. In this video, let us see the lead code problem number 172, that is factorial trailing zeros. Okay, so which is from medium level. So this is actually you can design in two ways. So one is to the extension of factorial model. So another one is so with the help of single loop also we can finish the solution of this. So first let me complete so finding factorial of a number. Okay, so have a look everyone. So that is program to find factorial of a number. So so you know this if you take input as so 5. Okay, so we should multiply values from 1 to n. So that is 1 to 5 here, so that you'll get the result that is 120. Okay. So actually some base cases are also included here. Okay. So for some negative values, we need to display factorial not defined for negative values, all this. But so just I am typing so the main logic here. Okay. Uh, so the thing is, we need to generate values from 1 to n here with the loop, for loop. And next of all those values continuously we need to multiply. Okay. Finally, we should go for printing the result. Okay. So multiplication model programs, we need to start so by storing result, storing variable to 1 here. Before to that, let us take input. So I'm taking input here. So with int of input, next it shall result I am taking to 1. Next I am generating values from so 1 to n here. So 1 comma start is 1, and if you want to generate up to n, we need to take stop as n plus 1 here. Okay. So next simple expression here, continuously result variable has to be updated. So with this expression result. Okay. So that is initially result it takes 1. Now you can start from so 2 also here. Okay, already we taken so 1, right? So 1 into 2 it becomes 2. Next iteration in place of result it takes 2, and in place of I it takes 3. 2 into 3 6. Likewise it continuously so updates result, and finally you'll get the factorial so value. We need to print that onto the output of screen. Okay. So let us check 5 factorial. So you can check. So for 0 factorial, you'll get 1. So it won't repeat the loop. Initially, we take a result 1, right? The same thing prints onto the output screen. Okay. So to the extension of this, actually, we can develop the solution. Okay. But what happens? Let us see all this in detail. Okay. So observe now, given an integer n, return the number of trailing zeros, okay, in n factorial. Trailing means you all know, so the ending zeros here, okay. Leading means beginning, trailing means ending, guys. So here, so factorial definition is given and some examples are given. So I'll explain. So here, all of you check it once. See, for 5 factorial result, you can check how many zeros were present at ending. So 1 0. Let us take 6 factorial result, only 1 0 is there. Let us take up to 9 factorial. Up to 9 factorial, you can check that only 1 0 you are getting. Okay. So from 0 to so 4 factorial result, so you'll get only 0 zeros, and for 1 factorial, sorry, 5 factorial to so 9 factorial, you'll get 1 trailing 0 at the ending. Okay. So next, so here I'm mentioning range and next of all trailing zeros. Okay. Now let us take so 10 factorial here. So check how many zeros we are getting at ending. 2 zeros. Likewise, if you check up to 14, you can notice one thing. So you'll get the 2 zeros at the ending. So that is 10 to 14. You'll get so the 2 zeros here, and 15 to 19. You'll get 3 zeros, and so for 20 to 24 you'll get 4 zeros. Okay. So you can check 24. So here we are getting so four zeros here, okay. But so if you take so 25 factorial, okay. So check how many zeros we are getting at the end. So exactly 1, 2, 3, 4, 5, 6 it is. Okay, if you check for so 25 to 29, you'll get the 6, not 5. So here you should notice one thing for every 5 multiples, one zero count is incrementing here, but for every 5 into 5 multiple, okay, uh, so here one extra zero is adding at the ending, okay? So means for 5 into 5, so 25 we are getting extra zero, right? Likewise, next of all for 25 into 5, so one more extra zero adds. One extra zero adds at the ending. So this is a concept you should notice here, okay? Based on this logic, actually we can trim the solution. So, but before to that, so I'll follow, first of all, I'll explain the basic approach also. That is, after finding the factorial of a number, so by retrieving, let us take 5 factorial result, that is 120. So we need to retrieve digits from the number. We should check whether it's 0 or not. Okay. If it is 0, we should go for incrementing the count. If not 0, we need to stop the loop. Okay. So already in some videos I explained how to retrieve the digits. Okay, with the help of modulus division of 10 expression. So by same thing you can use. Okay. So I'll explain the same solution. So first of all, check everyone. Okay. So for 3 factorial, no zeros at ending, 0 zeros. For 5 factorial, you can find 1 0 at ending, and for 0 factorial, 0 zeros. Okay. Here you can observe this follow up. Could you write a solution that works in logarithmic time complexity? Okay. Let us see this one later. So, but before to that, so let us complete in the regular form now. It is from math. Okay. As usual, after completion of this, go through. So the similar questions, guys. Okay. So let us see the coding screen here. Already trailing zeros method is given, n variable given. We need to return integer value from the method here. Okay. So first, let us complete finding factorial. Result is equals to 1 and generating values from 1 to n and multiplying so the values continuously here. Okay. So next, after that, we need to count. So number of zeros at ending, right? Initially, I am taking count variable to 0 here. Next, until result, so values are going to become 0. Okay, we should keep on repeat the loop. So we need to retrieve the digit. So here, with the help of this expression, result modulus division of 10. So if that digit is not equivalent to 0, then we need to stop the loop. Okay. If for suppose if it is equivalent to 0, we need to increment count by 1. Okay. After that, we need to reduce one digit in a number with the help of this expression. These two, I said, commonly we use in so far working with the digits in a number program, modulus division of 10 and so normal division of 10 expression update. So we use it for updating the so the variable here, okay, loop variable. So finally, on returning so the count, you'll get so the result. Okay. So let us check. Here, two loops are involved here. This one takes order of n time complexity. This one based on so the inputs here. Okay. So it's order of n here. So observe now. Next of all, so base test case executed here. Let us submit and check. See, it's taking more time in itself. We can understood that I need to reduce it. Yeah, check how much time it take a runtime 9037 seconds. Okay, it's just beating some 9.12% solution. That's it. So I hope so you understood. This is not the best one. So we need to find out so the logarithmic time complexity solution here. Okay. So let us do that. Okay. So but before do that, so you can notice one thing here. So for every 5 multiples, we are getting so the zeros, right? Okay. So means on dividing 5, 6, 7, 8, 9, all these values with 5, you'll get the quotient 1. On dividing 10 to 14 values with 5, you'll get quotient 2. Okay. Simply, you can return this expression, that is n divided by 5. Okay. So, but here the problem is for every, so 5 multiple, okay. So here one more extra 0 adds, okay. That is 5 into 5, 25, and 25 into 5, one extra 0 adds here, okay. So for that sake, you need to do one thing. So after getting the number of digits in a number of zeros in a factorial result, okay. So with the division expression, again, so we need to apply the same expression here, okay. So again, we need to check whether, so the result is n divided by, so 5 expression, so whether it's returning 5 multiple result or not, okay. If it is getting, so 5, or else if it is exceeding 5, again we need to apply the same operation of division of 5, so that one more extra 0 will be added here, okay. So I'll explain with the, so sample example here, okay. First, let me complete the solution here. Initially, I am taking count to 0 here, okay. So the thing is, here this expression is enough, n divided by, so the 5, okay. So but here, so for every 5 multiple, one extra 0 adds, right, okay. We need to repeat the loop. What I am saying here is, first collect this number of zeros count into some count variable here, okay. Later on, so do one thing. I'm not typing in sequential, okay. So to understood clearly. After that, so check whether, so that divided by 5 expression, so getting result 5 or not, okay. If it is getting 5 or more means, so it is the 5 multiple value, right? One more extra 0 we need to add, okay. So that's why I'm taking this expression now, okay, n divided by 5. If it is, if n variable is updating with 5 or else more of 5, okay, so then again we need to repeat this expression so that we can we'll get the extra one more 0 count here, okay. So now I am typing the loop condition here. So check everyone what I am saying. If n variable is exceeding, so the 5 or else exceeding 5, so then we need to repeat the loop here, okay. So finally we need to return the count here from the program. Let us take sample input as 25. So 25, let us check now, okay. So for 25 greater than or is equals to 5, it's true. So count is equals to 0 plus 25 divided by 5, it's 5. So now you can check n is equals to 25 divided by 5, it's 5, right? Now we can check. So here we are getting, so the 5 means it's a 5 multiple value. So once again, 5 greater than or is equals to 5 means it's true. We are going to get the zeros count here. 5 plus 5 divided by 5, it's 1. See, one more extra 0 we are adding here. Next time, so 5 divided by 5, it becomes so 1. 1 for 1, it becomes, so the condition false. Okay. Finally, it returns the count value 6. I hope you understood. Just if you take values from 5 to 9, so 5 to 9 values are dividing with 5, you'll get the count 1. Again, after so updating with the n variable with that expression, so it won't exceed so 5 or else more, okay. That's why in the first iteration itself it stops and it returns the initial count, okay. But for 5 multiples onwards, here one extra 0 will be added, okay. And so we can return the correct results for all inputs here, okay. So let us test and submit now. Check how much time it is going to take now, okay, when compared to the previous solution. As it's taking just 0 milliseconds, you're speeding 100% of all solutions, okay. So simply it's just on dividing input value with 5, we'll get count of trailing zeros in factorial of number, but for every 5 multiples it changes, right, okay. One more extra 0 adds, okay. That's why we are checking whether it's 5 multiple value or not. So by updating n, okay, if it is 5 or 5 multiple or else more than 5 multiple, it definitely this condition becomes true. Okay, if it is exceeding, so the 5 multiple means once again we need to collect the extra zeros here. Okay, we are running the loop. I hope so. Each and everyone understood the program here. Okay, so that's it. Thank you. Thank you.